Homework tonight is on page 226, 18 through 58, all 64 and 65. So what base do we work in? Anybody know what base we work in? All right, we work in base 10. Okay, we work in base 10. How many digits are there in base 10? 10 is correct. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 digits, okay? All right, so the number that we have up here, which is 5,632, 2 is in the ones place, right? 3 is in the tens place, 6 is in the hundreds place, and 5 is in the thousands place. So basically what we have in this number is 2 times 10 to the 0 power, because anything to the 0 power is 1, plus 3 times 10 to the first power, plus 6 times 10 to the second power, plus 5 times 10 to the third power. So that's really how that number comes about. Okay? What base do computers work in?
2.
Base 2 is correct. How many digits are there? 2. What are they?
0
Right. So base 2 has 2 digits, 0 and 1. Okay, what does a power button look like? Anybody know? Like that? Where does it come from? It comes from base 2 with a 0 and a 1, and they combine them to make the power button. Okay? All right. That's a little information y'all need to know, right? Okay. So up here, I have x to the third power. X is the base, and 3 is the exponent. So the power is 3, or the exponent is 3, and the base is x. Okay? So this number says, what is 3, 4, 6, base 7? What is that number in base 10? So how would you go about finding that number in base 10? All right, so let's talk about it. A few minutes ago we said, back here, we said this was the ones place, the tens place, the hundreds place, and the thousands place, right? And we wrote out how we got that. 2 times 10 to the 0 power, 3 times 10 to the first power, 6 times 10 to the second power, and 5 times 10 to the third power. So, going back to our question, what is 3, 4, 6 and base 7? All right, well, if you think about it this way, that's 6 times 7 to the 0 power, right? Plus 3 times 7 to the first power plus, sorry, that's wrong. Time out. Start again. So it's 6 times 7 to the 0 power plus 4 times 7 to the first power plus 3 times 7 to the second power. So that number, 346 in base 7, would equal what in base 10? Well, that's 3 times 49 plus 4 times 7 plus 6 times 1. All right, so what's 3 times 49, y'all?
147.
How much? 147. Plus 28 plus 6. So what is that number? 147 plus 34, right? So what do we get? 181? Do I have that right? So in base 10, 3, 4, 6 in base 7 is equal to 181. Okay? All right. Y'all are looking at me like, all right. So we could actually find out what this number was in base 10, but we're behind already in time, so we'll come back and do that later. So today we're going to start with monomials. A monomial is a number, a variable, or a product of a number and a variable. So a number like 5, a variable like x, or the product of a number and a variable. So 5x, or we could have xy. Okay, those are monomials. Okay. So up here, the rules for exponents are very important. You got to know the rules for exponents, and that's what the homework is all about. So up here, I have the first rule, says x to the m times x to the m. Notice the bases are the same. If the bases are the same, you're going to add the exponents. Okay, so this would be 5 plus 7. Which of course is x to the 12th. You don't have to write it out. Y'all can all look up here and see that 5 plus 7 is equal to 12. I've just written it out. This would be 1/3 plus 1/4. You would have to change these. This would be 4/12 plus 3/12, and you would get x to the 7/12. Everybody okay with that rule? All right. Let's put up one more example. If you have 2 to the 4th power times 2 to the 6th power, as long as the bases are the same, you're going to add the exponents. So are the bases the same?
Yes.
Yes, the base is 2 and they are the same. So you would add your exponents and get 2 to the 10th power. Okay. The next rule says x to the m divided by x to the n. You're going to subtract your exponents. So the example that I have up here, let's start with an easy one. So we'll say x to the 4th divided by x to the 2nd. You would subtract your exponents to get x to the 2nd. So here I have two a little bit more complicated. How many times does -5 go into 40, y'all? -8. The rule tells you to subtract your exponents, so you get x squared. Here, this is a little bit more complicated. -2 goes into 24 how many times? -12. Subtract your exponents, and we get c squared. Subtract 2 from 6, and we get 4. So the answer is c squared d to the 4th over -12. The next rule, x to the m parentheses raised to the n, you're going to multiply your exponents. So here you get x to the 12th. I don't care what they are. You could have another example might be x to the 1/3 raised to the 1/2. You're going to multiply your fractions and you get 1/6. All right. So the next rule says xy to the m. That's x to the m, y to the m. So here, my example, that's 3 to the 1st power, so that's 3 squared x to the 6th, x to the 4th, y to the 6th, so that's actually 9x to the 4th, y to the, I screwed that up, y to the 6th. Okay. A negative number raised to an even power is always positive. So this is -3 to the 4th power, a to the 4th power. -3 to the 4th power is 81, a to the 4th. Okay. Everybody okay with those? All right. Remember, we were talking about on matrices that a matrix was labeled with a capital A, and that a to the -1 was what? did we say that was equal to? The inverse. And what is the inverse equal to? The reciprocal when we're talking about multiplication. So what is this equal to? If you raise that to a -1, it's 1 over -2, right? Because it's the inverse. Everybody? Okay, so having said that, let's look at our next rules coming up. Anything raised to the 0 power is 1. So that's equal to 1, but this is 5 times 1, or 5. So what about this example? 8 over m to the 0 into the 0, that's 1 plus 1, or 8 over 2, which is in fact 4. The next rule says x over y raised to the m. That's x to the m, y to the m. So on this particular problem, we have 2 to the 4th power, z to the 4th power over x to the 12th, y to the 8th. You can leave it as 2 to the 4th, or you could raise it and you get 16z to the 4th. That's why I gave you one of those blue sheets, so that you could look on your blue sheet and figure it out. Anything raised to a negative power is 1 over the number to the power. It means take the reciprocal. So in this case, this is 1 over x cubed. And now let's talk about this one. Well, we already know this one is 1 over -2 because we've already looked at that. But I would like to look at this problem separately. So on this problem, this is x to the -4 over 1 times 1 over y to the -2. Okay? All right. So we know that this says to take the reciprocal of that, so that's 1 over x to the 4th. And that's taking the reciprocal of that. Well, what's the reciprocal of 1/2? 2. So what's going to happen to that? The reciprocal of that would look like this, right? So we get y to the 2nd, x to the 4th. All right, so once again, I have up here another negative power. Your answers on your homework tonight should not have any negative powers unless you're working with scientific notation. We'll talk about that in a minute. So this is actually equal to y to the m over x to the m. So what's going to happen here? This is going to be over 2 to the 4th raised to the 3rd. So this is x to the 6th over 2 to the 12th. All right, so I have some more examples up here. These are just examples. So if it's a negative exponent in the numerator, where does it move to? The denominator. And if it's a negative exponent in the denominator, where does it move to? The numerator, right. But notice what this problem is. These have the same bases, don't they? So the bases are the same, so the rule says you're going to subtract your exponents. Okay? So if we subtract, minus a minus makes it what? So we get x squared as an answer. So what do you see here? Are the bases the same? Yes. So what are you going to do with the exponents? Subtract them. So you have to be careful because you have to subtract the whole exponent, not just some of it. So we have x to the 2a minus 1 minus a minus 5. Everybody still with me? So 2a minus 1a is how many a's? 1a. Minus 1 minus 5 is minus 6. So the answer is x raised to the a minus 6. Okay? Alright, so now let's talk about scientific notation. Scientific notation is a way to write a number and work problems easily. To be in scientific notation, the number has to be between 1 and 10. It can be equal to 1, but not equal to 10. Okay? So, if we were to change this number 5,123 to scientific notation, we're going to move our decimal place 3 places to the left. That number is between 1 and 10. So 5.123 is between 1 and 10. And so times 10 to what power? The third power. If the number starts out greater than 1, the exponent's going to be positive. If the number starts out less than 1, the exponent's going to be negative. So 1, 2, 3, 4. We have 7.0723 times 10 to the negative fourth power. So because this number started out less than 1, the exponent's negative. Okay? Everybody okay with that one? Alright, so how is this going to be used actually? This problem is problem number 50 on tonight's homework. And so let's look at this problem because there's an easy way to work this problem and a hard way. And you don't want to do it the hard way, do you? No. Alright, first of all, multiplication is associative, so you can change the order. So if we change the order of this, are these bases the same? Yes. So what are you going to do with the exponents? Add them. So add the exponents and you get 10 to the 9th power. And if we multiply these two numbers together, we get 3 times 5 is 15, so we get 0.45, and 3 times 4 is 12. Is that number 12.45 between 1 and 10? No. So we'd have to rewrite this as decimal 1.245 times 10 to the first power times 10 to the 9th power. So 1.245 times 10 to the 10th power would be the answer. Everybody okay with that? All right. That takes me to the next type of problem. Everybody's good? The next type of problem. So copy this problem down. It's number 42 on tonight's homework, and you're going to see this again. It'll show up in logarithms and exponential functions. And so it's an important problem to understand and be able to work. I've written the steps down. You'll notice that you have 2 raised to the r plus 5 and 8 raised to the 2r minus 1. Are those bases the same? No, they are not the same. So you have to make the bases the same by changing 8 to some 2 raised to some power. So get out your blue sheet and find out what 8 is. 2 raised to what power? The third power. That's right. So we're going to make the bases the same by rewriting 8 in terms of 2. So then we have r plus 5 for the exponent for 2 there. But what does the rule tell us to do with our exponents here? Multiply them. This is the rule we're using. The rule tells you to multiply them. Okay, so we get 6r minus 3. As we're multiplying these together. Once we have the bases the same, this base is equal to that base, then we can set the exponents equal to each other. So we have r plus 5 is equal to 6r minus 3. So then we want to subtract, and we get 5 is equal to 5r minus 3. And we'll add to get 8 is equal to 5r, so r is equal to 8/5. Everybody okay with that one? All right, so that takes me to problem number 43 on tonight's homework. Ready, Cameron? All right, so on number 43, we have to combine these two before we work the problem. So what does the rule tell you to do with your exponents? Add them. So that's 3r plus 7. Once you have a single base here and a single base there, then you can set your exponents equal, and you get 28 is equal to 3r plus 7. So 3r is equal to 21. So r is equal to 7. All right, so here's some more random examples. Would y'all like to work these and then I'll work them?
If you need the on the board, then yes.
On your paper. Okay, y'all, so we have 3 times negative 4 times x cubed, x to the second, y squared, y to the fourth. So that's negative 12, x to the fifth, y to the sixth. Okay? Everybody okay with that one? How many times does negative 5 go into 30, y'all? Negative 6. And then 4 minus 2 is 2, right? How'd y'all do? All right, I'm going to see if I can stop this thing.